Welcome back. This is an Aleks training video on understanding how solubility varies with temperature and pressure. I think your experiences are enough to where you will know how to do this. I think you can get the right answers here. Let's look at a couple things first. If you want sweet tea and you want to make it yourself, you will put a pot on the stove with some water in it, put some tea bags in it, make it as strong as you want, and then while it's still hot, add sugar. You stir it up, put it in a jug, put it in the refrigerator, and cool it down, and that's how you make iced tea, sweet tea. If you want sweet tea in the restaurant, but they only have unsweet tea, and you get a cold glass of unsweet tea and you try to put sugar in it, it never gets sweet enough. You'll put sugar, it'll just sink to the bottom. You'll have an inch of sugar on the bottom of the glass, and the tea is still not sweet. So the first thing that you have learned is that as temperature goes up, more solid dissolves in liquid. Okay, so more sugar will dissolve in the water as the temperature is higher. Okay, the lower the temperature, the less solid dissolves. The higher the temperature, the more solid dissolves. Okay, now let's see about gases. The higher the temperature, all right, the colder the temperature, the more gases will be in water. Okay, the gases can dissolve in liquids too. And the colder the water, the more likely those gases are dissolved. If you've ever had a Coke that's cold, it's scrapier. Okay, because the carbon dioxide that's dissolved in that water stays in the water. Okay, so a cold Coke or whatever is going to retain its carbonation more than a warm Coke. You don't want warm soda. Okay, because what happens is the temperature as it rises up, it becomes less soluble to the carbon dioxide and the bubbles come out. And then it's flat and all you have is syrup, and that doesn't taste good. Okay, so as temperature goes up, more solid dissolves. As temperature goes up, less gas dissolves. Okay, a good trout stream is cold because the oxygen in the water is what the fish are breathing. Okay, if you were to have warm water, the fish would die if the water were too warm because all the oxygen would come out of the water and the fish don't have anything to breathe. Okay, so as the temperature goes up, less gas is dissolved. As the temperature goes down, more gas is dissolved. All right, now let's look at pressure. The reason why you pressurize a can of Coke is because the pressure increases the solubility of the carbon dioxide. So you have to have a sealed bottle of Coke. You have a sealed can of Coke. All right, and so when you open a Coke and it fizzes, that is the carbon dioxide above the water that's come out, and then it's trying to escape. Okay, so when you have pressure, the more pressure you have, the more gases dissolve in the water. But you're going to see that if the only thing you don't have experience, because you've seen that too, the warmer the Coke, it spits more, it fizzes more because all that gas has already come out of the Coke and is now sitting above the Coke, and when you open it up, it tries to escape real fast. If you increase the pressure, it does not dissolve solid any more or less. So there's no change in a pressure difference. Okay? All right, so to recap, higher the temperature, the more solid dissolves. The higher the temperature, the less gas dissolves. The higher the pressure, the more gas dissolves. The higher the pressure, it doesn't have an effect on the solid. Okay? So now I think you can answer the questions. So your question says, a student opens 2 cans of carbonated water. One is warmer than the other. Okay, so can A is warm, can B is cold. So you have to ask yourself, okay, what's happened in the can that's warm? Well, it's less soluble to the carbon dioxide. So some of that carbon dioxide's come out of the water and is sitting above the can, sitting above the water in the can. So when you open the warm one, what happens? Okay. This is the part where you make a think, and you go, okay, well, if it's come out, that means it's sitting above, that's pressurized gas sitting above that, and you open it up, it'll spit, okay? So that's what's going to happen. Can A, the warmer one, will make a louder and stronger fizz than can B. Can B, the carbon dioxide is still in the liquid. Can A, it's sitting above the liquid and wanting to get out of the can when you open it. Okay. The second one, a pair of 100 ml samples of salt water. So you've got a salt water well. Okay. The first sample was taken at the top of the well at 32 Celsius. The second one was taken deeper in the well at 42 Celsius. Okay. So the sample 1 is warm and sample 2 is very warm. Okay. Which one's going to dissolve more salt? The warm water or the very warm water? The hotter you are, the more salt would be dissolved. Okay, so they take them out. It says they initially, okay, both samples are allowed to come to room temperature and pressure, and the first salt water is some salt falls out to the bottom of the jar. You see a precipitate of salt. Okay, what's going to happen to the second one? So if salt fell out of the solution in the first one, what's going to happen to the second one that was hotter? The salt water was hotter. Well, if it was hotter, then more salt dissolved in the water. And so when you go down to room temperature, it can only hold so much salt at that temperature. And as it cools down, you're going to get more salt come out. Okay? So this whole idea is you have to think it through and ask yourself questions and then answer the questions based upon what you think. Okay? Hope you're getting it.